Hello, grade 11s. Welcome to this lesson about angle of inclination or the inclination of a line. And in this lesson, we'll obviously be learning how to determine this angle of inclination. Okay, and before we start, I believe you have something to write with and to write on. And the inquiry method here is straightforward. You want to ask yourself what type of angle is depicted, okay, by the given diagram. Okay, is it an acute angle or an obtuse angle? And look at the nature of the line. Does it have a positive gradient or a negative gradient? Okay, because then it will determine whether you will need to use a reduction formula or not, depending on the sign of the gradient. Okay, so let's start with this side right here. We have a straight line right here, and we see that our theta here is indeed acute. Okay, so we do not need a reduction formula, because remember in the cast diagram, acute angles are in quadrant 1, where all what? Trig ratios are positive. And in this case, we deal with one trig ratio, 10. Okay, and what else can we pick up? What is the gradient? We don't have to calculate it as yet, but we understand that there's an increasing function, therefore it has a positive gradient. Okay, the gradient is greater than 0. Okay, now determining this angle theta of inclination. The angle of inclination is it's an indication of the degree of steepness of the line relative to the x-axis or the horizontal axis. Okay, I'll repeat that one. The angle of inclination indicates the degree of steepness, okay, of the line relative to the x-axis or the horizontal axis. And this degree is obviously the angle that we measure, okay, or in this case calculate. Okay, so let's see. We have the following formula to aid us in calculating the angle of inclination. I just want to go a bit, one level deeper and discuss where this equation comes from. Tan theta equal to m, all right? M being obviously the symbol for the gradient. And you remember it comes from the standard format of the line or a linear function, y equal to mx plus c. Okay, so suppose we take these 2 points A, B, okay, and obviously we're going to use them now to calculate the gradient. But if we drop a perpendicular right there, okay, we produce a right angle triangle. Okay, A, B, let's say C. Okay, now what is happening? If we label it, the side opposite the 90 degrees is the hypotenuse. Okay, this is the position of our angle. The side opposite the position of our angle is the opposite side, and this will be the adjacent side. Okay, so we understand that if we are dealing with a right angle triangle and you want the trig ratio 10 of the angle that is inside that right angle triangle, it will be the opposite side over the adjacent side. Okay, that is the ratio that will help us to get tan theta. Okay, and in this case, it will be what? What does this give you? It gives you the vertical change in y. What does this give you? It gives you the horizontal change in x. So this is the difference in your x values. This is the difference in your y values between your 2 points of interest. Okay, so this is your change in y over change in x. Okay, and obviously if we now expand that, it means this. And what does this ratio give us? It gives us m. And this is where the equation comes from. Okay, I believe that is straightforward and clear for you. Okay, now we're going to apply. Let's get the gradient AB, the gradient of line segment AB. Okay, y2 minus y1 over x2 minus x1. Okay, so I'm gonna make this x1, y1. This is my second point. I'm gonna make it x2, y2. Correct substitution leads you to the correct answer. Okay, so y2, it's 1 minus, what is y1? 0. x2 is root 3 minus 0. Okay, so this becomes 1 over root 3. We want the angle now. We know that tan theta is equal to the gradient. What is the gradient? 1 over 3. Okay, and we now need to take the inverse, okay, or the arcturn. So we can take out our calculators now and type in there tan inverse 1 divided by root 3. Okay, so what do we get? We get 30 degrees. 30 degrees. Okay, so I just want to use the trigonometric way of solving trigonometric equations. Reference angle is 30 degrees. It's acute. We don't need a reduction formula. Therefore, theta is 30 degrees. We leave it there. Okay? Let's go to the second one. What do we pick up here? We see that our theta is indeed obtuse. Okay? Our gradient, decreasing function, gradient is less than 0. Okay? So here we will need to use a reduction formula because it's an angle that's greater than 90. Okay? So let's get the gradient PQ, y2 minus y1 over x2 minus x1. I'm going to make this one x1, y1, that's my first point. I'll make this one x2, y2, my second point. Then the substitution there, we have 4 minus 8, and then 1 minus, be careful there, of the double negative, it's a negative 3. So this gives us a negative 4 over 4, which is negative 1. Okay, gradient of line segment PQ is negative 1. Okay, so we bring in our formula, our equation, theta equal to m, right? And then your gradient in this case is negative 1. Okay, so your reference angle, remember we just take the tan inverse of 1, okay, in our formula to avoid confusion or a double negative in application of the reduction formulas. Okay, but I'll show you two techniques on how to still work with the, two techniques that the other one will involve the negative 1 as well. So tan inverse of 1 gives you 45 degrees. 45 degrees, okay? So we can clearly see that this is not 45 degrees. So we need to apply a reduction formula since theta is obtuse. So theta, therefore, is equal to what? Obtuse angles greater than 90 but less than 180, we're in quadrant 2. So we use 180 degrees minus our reference angle. Reduction formula, reference angle being what? 45 degrees. So your theta is 135 degrees. Okay? Or you can do it like this. You can say theta, if you prefer to work with the negative, it's still fine. Tan inverse of negative 1 plus 180 degrees. Okay, so the negative 1 now means you are going in the clockwise direction. Remember, for positive angles, we're going to in an anti-clockwise direction. So you're here now. So you're saying that is what? 45 degrees. But that is not in the position of theta. Theta is here. So then you go back, you add 180. So that's why you add 180 degrees. So actually this gives you a negative 45 degrees plus 180. So negative, I just explained now, you go in a clockwise direction, but you add 180, and this still helps you arrive at the same answer there, 135 degrees. Okay, remember angle of inclination is the degree of the steepness of the line relative to the x-axis. Okay, so this is the degree of steepness, and what is the degree of steepness? Okay, I believe this was helpful, guys. Thank you for tuning in. I'll see you next time, and do more of these exercises and as much as you can. All right. So yeah, see you soon. Sharp sharp.